So welcome to my presentation. I'm going to talk about neural implicit representations, which is something that we have been working on for a few years now, and it's really becoming a trend. And I want to show you what we have been doing, but also what other applications there are for this type of models. So here's the overview of my talk for today. I will first introduce implicit neural representations in the context of 3D reconstruction, and then talk about how to learn these representations without 3D supervision by just looking at images. Then I will move on to another representation that's related to that representation that I presented before, called neural radiance fields, and in particular some generative approaches that we have been developing for unsupervised learning of neural radiance fields. And then finally, I want to highlight some diverse applications that we and others have been pursuing in this or using these representations. So let's get started with the first part on implicit neural representations. Probably most of you know the 3D reconstruction problem, right? So the goal here is to reconstruct from a set of images a 3D shape. So a classical 3D reconstruction pipeline could look like this. The input is a set of images. We first determine the camera poses, for example, using sparse structure from motion, bundle adjustment. And then once we have the camera poses, we can find dense correspondences between nearby views, for example, using the apipolar constraint. And this gives us a set of incomplete 3D reconstructions. One example of such a reconstruction is a 2.5D depth map, which we can then combine into a coherent 3D model of the object or scene. Now, this is all nice, but of course, now we have machine learning, and so there is more and more 3D data sets now becoming available. And so the natural question to ask here is, can we use these 3D data sets to learn 3D reconstruction, maybe even from a single image? So this is the first setting that we were going to look at. So the task is from just a single RGB image, we want to reconstruct a 3D shape. Now, an important question to ask is, what is a good representation? Well, the input is clear, right? It's a 2D image, and so we know how to process images. We have convolutional networks or vision transformers more recently, so we have very good models for processing, or that take an image matrix, a pixel matrix as input. But what should be the output